show you guys how to run an LLM locally. One of the reasons why you might want to do that is because you might have proprietary data that you don't want to send to OpenAI. And so this is a way where everything stays on your local computer. And it doesn't have to be your local computer. It could be any environment that you control. So for example, in AWS instance or stuff like that. Now the one gotcha is that the version that we can run right now, is very limited. The best way of thinking about it is kind of like a toddler. Like you ask a toddler, or like a little kid. You ask a little kid a complex question, and maybe like halfway they forget what they're talking about, and they talk about something else. And so the model that we can run right now is like that. And the reason why we can only run that model is because there's a bug right now in LLama CPP, which is what we're using to run the model, that keeps a high resolution model from loading. So right now the only thing we can run is Llama 13B, which is really good, but only the 4-bit model, which has very low accuracy. So we're kind of limited by that. And we're also limited by tokens, by the number of tokens, but there's with better models, there are workarounds that I'll go over. And then of course you can only use Llama for research purposes right now, at least this version. So here, without further ado, let me show you guys how what you do. So what I probably should start off with is this diagram here, like why. So normally, if you want to give an LLM extra data, right? You want to the process that you do is you retrain it with that data and you generate another LLM, right? I haven't tried this route, but there's a simpler approach that you can use. Namely using a vector store. So the way the vector store works is, think of it like a database, right? So here's your documents, and you use this thing called an embedding, right, to basically map documents into the vector store. So think of it as a database, and then your LLM, it makes queries like against this vector store. And instead of ingesting all of the documents, it only sees the documents that are relevant to the query. And the gotcha, right, is that you have OpenAI. It can process very large documents, 32K tokens, right? So here's a visual representation of that, right? So it has a lot of memory to look at a lot of context. And a model like Llama CPP has a very small window, right? It can only process around 2K tokens. And so maybe it can't process all the documents at once. And so there are strategies that you can use. So for example, refine, rank, and stuff. Which here's the very first thing that we need to do, setup. So the first thing I recommend is to install Conda. You don't want to install alpha libraries on the Python libraries that are used by your OS, right? So do yourself a favor, run Conda, and install call it a Conda environment so that everything is containerized. It's basically like a poor man's version of Docker, right? So highly recommend you do that. Don't skip that step. Next thing is you want to download the model from Hugging Face, right? So this is the one that works with Llama CPP, and this repo is massive. It's like 60 or 90 gigs, and so you want to install git LFS so that you only download that one file. I had written this to use this model for the embeddings because supposedly it's better than the default Hugging Face embedding, but trying it out locally, it's slower and it doesn't seem to do any better job of embedding, so you might as well skip that stuff and just use the default Hugging Face embedding, right? This is the code to load Llama. One of the things that I want to point out is that we're using a toolkit called LangChain, which does all of the heavy lifting for us. And so, for example, loading documents from a repo is literally this hard, I should say. Like all this other stuff is just stuff that I have here so that I'm not reloading these files every time I run the notebook. But other than that, the main idea is just these two lines, right? This will load your repo, right, and put it into a format that can be shoved into the vector store, right? Next up is you have to chunk your documents. So before putting the documents into the vector store, you're going to actually split them up into smaller chunks, right? And this is how you do it, these 3 lines here. And next up, you load your embeddings. So here we're loading the default Hugging Face embeddings, right? Then load the vector store. That's actually Feist. The one that I'm using is Chroma. This one has a slightly better API. You can save it to a file, a directory, so that you can, so that you're not having to recreate the vector store every time you run the notebook. Feist has that ability as well, but it was not well documented. So I decided to go with Chroma. And then the next thing is you want to set up your, coordinate, make everything go together, right? So you load your vector store, your documents, you chunk them, you load your vector store here again. Okay, so this is the one that gets loaded. If it already exists, this is the branch that loads when it already exists. So this is the first time, this is the happy path, the first path, right? So you load your documents, you chunk them, you load the vector store, and that's it. That's pretty much it. That gets your vector store ready for consumption by the LLM. And so the next thing is to set up the queries. So here we're setting up what's called the stuff query. So basically the idea is that you shove everything into as much as you can into the context. So here's a visual representation of this right here. So basically these are the documents that come from the vector store, and you basically try to shove as many as you can, right, into the context window, right? And so this one actually is the best one because the LLM just sees more things, but because it has a very small token window, right, most likely you will get this error, right, where you run out of too many tokens, right? And so what I'm actually doing here is I'm actually only sending the first 2 matching documents. So even though this one has the most potential, right, it's very limited because we're only sending 2 documents. And so the next strategy that we can do is we can refine. So basically this is what we're doing here. So basically, given the context information, so I always get refine and the other one confused. But here's the visual representation of that, right? So on rank, yeah. All right, so refine, basically what you're doing is that you're looking at one document at a time. So you get it. So these are the documents that come from the vector store, right? And you send them to the LLM one at a time, right? So maybe you send that one and you get back food. Then it's called refine because in the next step, right, you tell the LLM that, okay, given this answer, right, can you make it better using this new piece of information? And then maybe you'll get another answer. And then the third step, you do the same thing again. Hey, given this new revised answer, can you make it better with this new information, right? So this one is actually sounds very awesome, very promising, right? And here's how you set that up here in LLM. So here I am setting up the initial template, right? And the template for subsequent things. So a couple things here we're talking about, right? So the first one is that notice how we're talking to the LLM in natural language, right? So these are literally the templates that serve as the instruction for the LLM to do its thing, right? So it's not code, it's not conditionals, it's just natural language. So that's kind of like a little bit of a handshake that needs to happen, right? So, and so that's how you set it up, right? So far so good. The problem though is, remember, we're using that LLM that's very limited, right? That very low resolution or low LLM that works like a toddler. And so what happens is that this toddler LLM will ignore your instructions, right? And it won't refine. And so you won't get back a full answer. Right? And so here's another thing that we could do as well, called query rank. And so this one, what you do is you basically do one document at a time, right? But you tell the LLM to rank the answers, right? So maybe to tell, so maybe for doc 1 it says, here's my answer, I think the score is 78. For doc 2 maybe the score is 81, and for doc 3 maybe the score is 99, right? And then the answer is going to be the one with the highest score, right? So this is another promising strategy that you can use. The problem, as you might have guessed with our toy LLM, is that it will ignore the prompts to give an answer. So it will often just not give an answer at all, right? So let's look at some sample results to see what I mean, right? So here we load, get everything going. We load these. So what I'm ingesting into the vector store is I have a GitLab repo that's sort of a moderately sized monorepo with TypeScript and TSX files and Markdown files. And then we load the LLM. And here we tried a query rank, right? So I asked it, how do we use a hamburger menu component? Because that repo that I use has this thing called a hamburger menu. So basically, if you go to like a website and you see something that has like 3 little dots, it's just a little menu button, right? And it says if it has four matching chunks. And this one gives a score of 100, right? That use the hamburger menu component for hamburger menu is correct. When the user clicks on the menu, blah, blah, blah. Let's see. Hide the body under hamburger menu component. Additionally, when the menu is visible. Yeah, I mean, it's looking good, but then it sort of kind of like forgot what it was doing and sort of left it incomplete. And then this one here just ignored the prompt altogether and didn't return anything. And then here, this other one here, the score 95, it sort of, as you can see here, it sort of started to hallucinate. I don't know, it started to give me Python code and importing this thing called the React burger, which does not exist at all. So it's a very funny answer, right? Then it crashed because the subsequent answers weren't formatted properly. All right, so let's look at rank or refine. So here, we answered the same question, right? The first, the first answer is always seems to be the best, right? To use the hamburger menu component first import it, right? From the hamburger menu model module, which is true, blah, blah, and then it even provides some sample code. It started to write the code, which looks correct, and then it kind of forgot. And then the second answer is, let's see, and notice also that these answers were supposed to, let's see, oh yeah, this is the refined one, so it's supposed to build on that first one, and we get back the same answer. And then in the third response, it actually eliminated stuff. And then in the fourth response, it looks like it's starting to hallucinate. So in this case, it appears that the first answer was the best, right? And then last, I tried query stuff. So how to use the hamburger menu component, the 2 matching chunks, these 2 files, right? And it's looking pretty good. And let's see, hamburger menu, blah, blah, blah. So it's actually not that good of an answer. So another thing I should point out is the time that it takes. So this one is, 197, having a brain fart moment. So 197, that is about 197 seconds. Wow, that is a pretty long time to give us an answer. So to recap, let's see what we have right now. So right now, we basically have a toy model that is not giving very good answers, but it does have a lot of potential, I think. I think one of the things that might help here is if we could adjust things like the temperature to make it not hallucinate as much. And definitely, if we can run a better model, that'll make it so that it sticks to the formatting, right? So next steps, right? So there's actually a new package out there called the VLLM, and so it offers a 24x memory improvement. So meaning if we are able to run it on our Macs, we should get a pretty big performance boost. Like basically maybe running better models and running them faster. So that promises to be very awesome. There are also open source models. So there was I think Falcon and Red Pajama, right? So these can be run in production environments. So that's also something to look at as well. So that's it.